Welcome to Chapter 4. We're going to combine Lessons 1 and 2. Our objective, learn to evaluate expressions with exponents. And our essential question, how do I compute a positive number to an integer exponent? Some vocabulary that's important when talking about exponents is the word exponent, exponential form, base, and power. If a number is in exponential form, the exponent represents how many times the base is to be used as a factor. A number produced by raising a base to an exponent is called a power. Both 27 and 3 to the third represent the same power. So in our example, 2 to the 7th power, 7 is the exponent, 2 is the base. If you're asked to write in exponential form, that means there needs to be an exponent in your answer. So 4 times 4 times 4 times 4, there's 4 of them, so it would be 4 to the 4th. In example B, we see 3 negative 6's, which would be negative 6 to the 3rd power, or negative 6 cubed. Pay attention to the fact that the negative 6 is in parentheses and the 3 is on the outside. We can do this with different terms as well. We have 2 5's, which would be 5 to the 2nd power, and 4 d's, which would be d to the 4th power. And we write them side by side just like multiplication. Simplify means find out what it actually equals. So 3 to the 5th power would be like 3 times 3 times 3 times 3 times 3, or an equivalent of 243. Negative 3 to the 5th power would be multiplying the number negative 3 5 times. Since we have an odd amount of negatives, our answer is going to be negative, and we already know that it's 243 from the previous problem. Always use parentheses to raise a negative number to a power. What happens if the negative is on the outside? This represents 5 to the 2nd power times negative 1. Because 5 is the only thing with the exponent, it would be 5 times 5, and the negative just goes in front of one of the numbers. So 5 times 5 is 25, times the negative 1 would be negative 25. What happens if we have negative exponents? Any non-zero number raised to a negative power equals 1 divided by that number raised to the opposite or positive power. So you can see the examples, 5 to the negative third is the same as 1 over 5 to the positive third. Here it is up close. 1 over 5 to the third would then be 1 over 5 times 5 times 5, which is 1/125th. What if it's negative 10 to the negative third? Simple. Put a 1 on top, put a negative 10 on the bottom, raise it to the 3rd power. So we get 1 over negative 10 times negative 10 times negative 10, which is 1 over negative 1,000, which could be written as a decimal as well. 4 to the negative second. Well, we know 4 to the positive second would be 16, so this is 1/16. Negative 7 to the negative fourth. 1 over negative 7 to the 4th power, which is 1 over negative 7 times negative 7 times negative 7 times negative 7. 1 over 2,401. And finally, the 0 power. The 0 power of any number except 0 equals 1. So 100 to the 0 power is 1. Negative 7 to the 0 power is 1. As long as 0 is not the value of the base, it will equal 1. So let's evaluate. Following order of operations, we have parentheses and exponents. Parentheses comes first, so we start with 6 minus 4 and get 2. Now we would do the exponents. 2 to the negative 3rd power is the same as 1 over 2 to the 3rd power, which is 1/8. Negative 2 to the 0 power equals 1. 5 minus 1/8 plus 1 is 5 7/8. What if we have to evaluate? Looks kind of messy. We have x, parentheses y to the x minus z to the y plus x to the y. for x equals 4, y equals 2, and z equals 3. Start by carefully plugging in your values to the correct places. So we get 4 times the quantity of 2 to the fourth minus 3 to the second plus 4 to the second. We have parentheses, and inside parentheses we have exponents. 2 to the fourth is 16, 3 to the second is 9. In parentheses, 16 minus 9 is 7. 4 times 7 is 28, and 28 plus 16 is 44. Finally, a geometry application. Use the expression 1/2 parentheses n squared minus 3n to find the number of diagonals in a 7-sided figure. N represents the number of sides, so we would substitute 7 in for n and solve. So we would start with 7 squared, 49. 3 times 7, 21. 49 minus 21 is 28, and half of 28 is 14. So there are 14 diagonals in a 7-sided figure. Here's what this would look like. There are your 14 diagonals. Exponents help us get through problems faster by combining terms for multiplication rapidly. Make sure your Cornell notes are filled out completely. On the left-hand side, write questions that can be answered from the material in your notes. And review your notes, highlight, underline, etc., and complete the summary before class.